Okay, guys, for this part of the lesson, we're going to learn how to use a function table, an input-output function table to sketch our quadratic. So just like with identifying key features such as the vertex, the AOS, the y-intercept, and the possible x-intercepts to graph, with this method, making a function table, we still need to find the vertex. So the vertex of parabola is one of the most key features of an actual quadratic function. It is the turning point. And this turning point, as you may recall, is either the maximum point or the minimum. It's either the lowest point of the function or the largest point, the highest point, we should say. So we're always going to want to find our vertex. And let's recall that our vertex is going to be the x-coordinate, which is your AOS as well. The axis of symmetry value is negative b over 2 times the a value. That's going to be your x-coordinate. And then to find your y-coordinate, for any function, you plug in that x value into the function to get the output value. And we're just going to call it the y value or f of x. So to find the y value, you plug the x value into the function. So we use the notation f of that negative b over 2 times a value. And then this is your ordered pair, x comma y. So our x values again are our input values. We put in a value in for x into the function, and then we do the math using order of operations to get out the y value. So we have an input, which is our x values, our domain, and then our output values, the y values, is our range. So if you recall, with most quadratics, unless there's some limitations if we're talking about word problems or real life situations, we are not restricted with our x values. So first of all, let's find that x value. So the x coordinate of our vertex is going to be negative from the formula times the b value, which is 28, over 2 times the a value, which is 7. So we get negative 28 over 14, and that gives us a value of negative 2. So our AOS is negative 2, which is also the x-coordinate of our vertex. So I'm going to let this be our vertex. Now let's find the y value when x is negative 2 by plugging in negative 2 everywhere we see an x into our function. And we're going to square the negative 2 first. So exponents before we multiply, order of operations. So that's 4 times 7, which is 28, minus 28 times negative 2. That's why it's a minus, because it's going to be negative here. That's 56. And then plus 32. And then 28 minus 56 plus 32. I like to combine my like signs. So this is going to be, that makes 30, that's going to be 60 minus 56. So y equals 4 when x is negative 2. So this is our vertex. So I am going to erase this work and now show you a good practice of finding 2 points to the left of the vertex and 2 points to the right. And again, we could use any x. We could plug in, 20, negative 50. We could plug in anything, but we want to be smart. And let's go ahead and just sketch the vertex, negative 2, comma, 1, 2, 3, 4. So about right here. We know this turns up because it's positive a. So we're not going to have any x-intercepts. There's no real solutions. So this method is great for when we don't have any x-intercepts, because having 2 x-intercepts gives us 2 points of our parabola. And personally, I like to have 5 points to see a better sketch of our parabola. So the more points, the more accurate our graph can be. So we know this is going to turn up. I'm going to sketch in my AOS, that is at -2. So I like to go a unit to the left. So that's going to be when x is -3. And then I like to go a unit to the right. That's going to be -1. And I like to put my x's from least to greatest. So we're going to have 1 point to the left of the AOS, and then we're going to have 1 point to the right of the AOS. So we'll plug -3 into the function, and then, or we could plug in -1. So let's just, because these two, -3 and -1, when we plug those in, those points are going to be equally distant from our vertex. So they're going to have the same outcome. They're going to go up the same amount. So we only have to find one of these, and I'm going to choose the -1. So this time, let's plug in -1 for x. Order of operations, square the negative. That gives us 1 times 7. 28 times -1. And then plus 32. Again, I like to combine my like signs, and so that's going to give us a 39 minus 28, and then this gives us, it looks like 11. So -1 comma 11, and then we would have -3 comma 11. If I plugged in -3, it would work out that y equals 11. So that's 2 more points. So -3 comma 11, we'll just sketch it out, and then our -1 comma 11, so they are equally distanced 1 unit on either side of your AOS. Okay, now let's go 1 more unit to the left and 1 more unit to the right, so that will put us at 0 to the right of the AOS, so that's 2 units to the right, and then this point, that was -3, this is -4. So obviously, plugging in 0 is going to be the easiest. So whenever we plug in 0, this is actually going to be our y-intercept as well. And so we get y is 32 because 0 times anything is 0, and another 28 times 0. So we get out 32. And then our other point, -4, would be 32. And so way up here, we'll say this is